This video we're going to be talking about fractional exponents. Now just another way to look at this is the word rational, right? And rational refers to any value that can be expressed as a over b, where a and b are both integers, right? So they are nice, pretty, positive, and negative numbers. So we're going to be talking about fractions and fractions that are expressed as exponents. Also, just a little bit of vocabulary. So the value that's here is referred to as the index, right? When we don't write anything, that index is automatically 2. The symbol here is actually called a radical, right? So when we refer to radical, we're referring to all values of indices, square root, cube root, fourth root, fifth root, that kind of stuff. This would be called the radicand, A-N-D. And of course, in here, that would be our, power or exponent, okay? So this idea of fractional exponents is going to really combine the exponent and the index. We'll see more to be revealed. The big piece here is do not rely on your calculator, right? Just do the best that you can. So 64 to the 1/2 power gives us a value of 8. And you think, well, wow, that's interesting. I know that the square root of 64 is also equal to 8. 36 to the 1/2 power is equal to 6. Oh, that's interesting, because the square root of 36 is equal to 6. Now, just for a sort of like sidebar, I know that right now 64 is being raised to the first power, and we said if we don't write any number in the index, it's automatically a 2. So this is the square root of 36 to the first power. Oh, there's the 1 and there's the 2. So that means that 25 to the 1/2 is 5, 16 to the 1/2 is 4, so 9 to the 1/2. It looks like this is the square root of, must be 3. Square root of 100 is 10. So another way to write the 1/2 power is to say that it is the square root of x, right? And there we have it. So then again, we jump to the 1/3 power. Now I know that the cube root of 64 is 4, or 4 times 4 times 4 is equal to 64, right? So since 4 to the 3rd is equal to 64, then the cube root of 64 is 4. Likewise, the cube root of 27 is 3, because 3 to the 3rd is 27. The cube root of 1,000 is 10. The cube root of 216 is 6. The cube root of 8 is 2, because 2 times 2 times 2 is 8. And the the cube root of 125 is 5, because 5 times 5 is 25, and 5 25s is 125. So I guess, again, the third root is just the x to the 1/3 power is just a fancy way of saying the third root of x. Now notice, this is automatically this. Otherwise, we do have to indicate. If it's not written, it is automatically a 2. Otherwise, we must put the value there in the index. All right, so the index defaults to 2 unless we override it with a different value. Let's keep moving. Okay, before we move too far, just notice that this has been scratched off. This is not 1,000. That should be 10,000 to the 1/4 is equal to 10. All right, so as you notice, we're amping up the denominator in this fractional exponent, right? So we're changing that index. So now we're talking about 625 raised to the 1/4 is 5. 81 raised to the 1/4 is 3. 10,000 raised to the 1/4 is 10. And these answers are the answers that they are, because when you turn around and raise 10 to the 4th power, you get 10,000. When you raise 3 to the 4th power, you get 81. What happens to 16? What to the 4th power gives me 16? Well, that's 2, right? 2 times 2 gives us 4, times 2 gives us 8, times 2 gives us 16. So that's 2 to the 4th gives us 16. And so by that rationale, then x to the 1/4 should be the 4th root of x. Therefore, if we look at 1 over x to the 1 over n, then I guess that means that we're talking about the nth root of x, right? That's the nth root of x. And that n is a default 2, unless we write an index indicating otherwise. So just to recap, the nth power of x can be written as x to the, right, there's the first power right there, so that's 1 over n. And x to the 1 over n can be referred to x as the nth root of x. Okay, and this is a 1. So let's rewrite the expression. So we have the fourth root of 5. So I guess that's going to be 5 to the 1 over 4. The 10th root of 3 is going to be 3 to the 10th, 1/10. There's no number here. So again, remember that's a 2 by default. That's going to be 7 to the 1/2 power. Again, we're just rewriting. We're not evaluating, right? Evaluating would be to go figure out the value for that. 5 to the 1/3 would be the third root of 5. 4 to the 1/6 would be the sixth root of 4. And x to the 1/2 would just be the square root of x. And notice I would leave the index blank, right? I would probably add this to my notes that the index is default to the value of 2 when blank. So right here, this value right here is a 2 when I don't write anything, in the absence of another. Otherwise, I must write the value, right? If there's nothing here, it's a 2. Okay, so my advice is go slow, think first. Good life advice, right? Go slow, think first. I didn't say think fast, right? Fast is generally when I get into trouble. So when simplifying cube roots, you need to know perfect cubes, right? We need to understand it. So we wrote this a while back, right? So 64 is 4 to the 3rd, and 5 to the 3rd is 125, so on and so forth. So we want to make sure that we have some of these available to us. So I think you should know at least through 5 to the 3rd. Okay, so examples. 27 to the 1/3 is going to be the cube root of 27, which is 3, right? Because 3 to the 3rd is 27. And I know that 10 to the 3rd is 1,000, so that's 10. And then we have this 729 to the negative 1/3. Now first, that's going to be 1 over 729 to the positive 1/3, right? That's our exponent rule because of the negative. And then the cube root of 729 is going to be the rewrite there. So that's the cube root of 729, which is 1 over 9, because the cube root of 729 is 9. So 729 to the negative 1/3 is 1/9. And then doubling back to the 125, sorry, I kind of jumped around there. That's 1 over 125 to the positive 1/3. And we know that 125 to the 1/3 is the cube root of 125. And the cube root of 125 is 5, as stated up here. So 1/5. So that is 1/5. Again, this is sans calculator, right? We want to be able to do this without a calculator. Now again, perfect fourths, you might want to grab these into your notes again, right? Just keep rewriting them, right? The more you write it, the more you learn it, right? So 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256. So then that would mean that the fourth root of 625 is 5, right? Because 5 to the 4th is 625. And the fourth root of 81, well, first we need to deal with the negative, right? So that's going to be 1 over 81 to the positive 1/4, right? Because that's our rule. If we see a negative, we shove that down to the denominator, make it positive. Or if it started negative in the denominator, we'll push it up to the numerator and make it positive. From here, we want to convert 81 to the 1/4 to the fourth root of 81. And I know that the fourth root of 81 is 3, so 81 to the negative 1/4 is 1/3. Perfect fifths, 2 to the 5th is 32, 3 to the 5th is 343, and 4 to the 5th, just for the record, is 1,024. And look at that. Now, let's just take one further, right? We're going to have 100,000. Now, I know that 10,000 is 10 to the 4th, so 10 to the 5th is probably 100,000. Okay, so we're just kind of jumping a little bit there from the 1,024. So we got the 1,024 to the negative 1/5. Again, first, I'm going to say, well, that's 1 over 1024 to the positive 1/5. And then I'm going to say that that is the same, right? I'm going to convert the 1/5 to the 5th root of 1,024. And then I'm going to say that that is 1 over the 5th root of 1,024 is 4. So 1,024 to the negative 1/5 is worth 1/4, or 0.25. 100,000 to the 1/5 is going to be the 5th root of 100,000, which is equal to 10. That's it. So again, just try not to jump too many steps, right? Go slow and think about what you're doing, right? If you rush, you will make a mistake. Okay, so now we want to take this to the next level and blend in a few rules. So I know that 25 to the 1/2 is the square root of 25, or it's just 5, right? So there's two ways I can look at this. So first I want to look at the exponent rule. 25 to the 1/2 raised to the 3rd is 25 to the 1/2 times 3, which is 25 to the 3/2, right? So what happens when I see that 25 to the 3/2? I can pull it apart as noted here. But also, I know that 25 raised to the 1/2 is like saying 5. And 5 to the 3rd is 125. So I guess it depends on what the instructions want me to do. Rewrite this as a rational or fractional exponent, simplified, or do they want me to evaluate the piece as a whole and come up with a final value? So these are both acceptable methods of looking at what exactly is 25 to the 1/2 raised to the 3rd. All right, let's push on. So 8 to the 1/3 would be the cube root of 8. And just doubling back, 25 to the 1/2 is the square root of 25, which is equal to 5. And by the way, the cube root of 8 is equal to 2. Now 8 to the 1/3 raised to the 2nd would be 8 to the 1/3 times, technically that's 2 over 1, so that's 8 to the 2/3. And now if we come down to here, well then what is 8 to the 2/3? Well, that's technically the cube root of 8 squared. And by the way, the cube root of 8 is 2 squared, which is 4. X to the 1/4 would be the 4th root of x. And x to the 3/4, again, this is that index, so the 4 goes out here, x to the 3rd goes in here. Okay. It's a great word, exponentiation, for fractional exponents. Okay, so we're just trying to tease back and forth. So how can we take that fractional exponent and write it as a radical that's raised to an exponent that I recognize? Okay, so this is going to be, right, the denominator is your index. That's the key piece. So 64 to the 2/3, that 3 is your index. The 4 here is your index. The square root here is your index. So that's going to be the 3rd root of 64, and all of that is going to be squared. Now, I know that the 3rd root of 64 is 4, so that's going to be 4 squared is 16. So 64 to the 2/3 is 16. Just for the record, I could use my calculator to check my answer and notice that we do have 64 raised to the 2/3 power is 16, right? But we want to be able to do this without a calculator, so let's keep going. So we have 81 to the 3/4 power, okay? So we're going to say that's 81. 4 is my index, and we're going to raise all of that to the 3rd power. Now the 4th root of 81 is 3. Raised to the 3rd power is going to be 27. Okay, let's keep going. 16 to the 3/2. Again, that's simply the square root of 16 raised to the 3rd power. The square root of 16 is 4 raised to the 3rd power is going to be 64, as we just stated up above. Okay, the next one is going to be the square root of 100. raised to the third power. The square root of 100 is 10. Raised to the third power is 1,000. 1/4 to the 1/2 power is going to be the square root of 1/4, which is the square root of 1 over the square root of 4, which is 1/2. Okay, 1/4 to the negative 1/2 power. Okay, so now this gets a little tricky. I'm going to hold off for this one for last. I'm going to say 16 to the negative 3/2 power is going to be 1 over 16 to the positive 3/2 power, which is 1 over the square root of 16, all raised to the third, which is 1 over, right, all raised to the third. Square root of 16 is 4, which is 1 over 64. Now, if you wanted to check your answer, you could certainly go to a calculator like Desmos to help you out, but you will not be afforded the opportunity to use a calculator in the assessment portion of this game. So just for the record, know how to do this without a calculator. And that went pretty quick, so you may want to go back and just rewatch this whole thing. It took 3 minutes to do that. Maybe worth another 3 minutes just to make sure you have this all solidified before you move on to the final problem here. So here we go. In simplest terms, I want to take a look at this problem here in a different light. Okay, so first we know that if we had AB raised to the m power, that would be a to the m, b to the m. And if we had a over b, all raised to the m, that would be a to the m divided by b to the m. Now, this is the idea that I want to take off of, right? So if I have 1/4 raised to the negative 1/2, right? I have 1 raised to the negative 1/2 over 4 raised to the negative 1/2. And my exponent rules say that if I have 1 over a to the negative m, then that's going to be a to the m, a to the positive m by putting it in the numerator, right? So 4 is going to be raised to the 1/2 in the numerator, and it becomes positive. 1 ships down, and that becomes positive. So essentially what I'm looking at is the square root of 4 over the square root of 1, which is just 2. Wow, that was a lot of work to get all the way to 2. Well, now that I understand it to be that way, if I see 1/4 raised to the negative 1/2, right? If I see this to begin with, I can say, oh, well then that's 4 over 1 raised to the positive 1/2, which is the square root of 4 over the square root of 1, which is just 2 over 1, which is just 2. Done. If I see a fraction raised to a negative exponent, I'm just going to flip the fraction over. So for another example of just that flip piece, if I had 2/3 raised to the negative 1/2, then that's equal to 3/2 raised to the positive 1/2. Now, that's not going to be a pretty answer. That's going to be the square root of 3 over the square root of 2, which again, square root of 2 is irrational, so I would have to rationalize that denominator. I would get the square root of 6 over 2. But the point of it is just going from here to here. Could you make that happen, right? Don't worry so much about the final piece. All right, we're just using the reciprocal and changing it to a positive exponent. And that's about it for us today, folks. So we'll see you next time. Take care.